This is Wednesday, right? Probably not Friday, probably Monday. I'll probably finish this stuff up on Friday. Now, if you remember that we always previous said that our angle was, the initial side was where? The positive x-axis, right? Out here. And so we were, oops, I thought I was getting red. This is our initial side. And which way was positive angle? It's counterclockwise, isn't it? This is a positive angle. Now, what we're going to do, they add confusion to it. What we're going to do is, if we're talking about bearing, so this is bearing, we're going to measure everything from here. And a positive angle is going to be this way. So you have to, it's totally different than, I told you the example, my GPS system or my on my pivots, this is the way they measure stuff. And then they say positive angle that way. And it's always from north. So you got, and then you got to remember which way is positive and which way is negative, and where you're going to, you know, if you have a draw over here, you certainly got to understand where you're going to set your pivot up to not go through the draw, what the angles are. And you know that you're not measuring from here up, but you're measuring from here, and then you're going to reverse your pivot and come back around and go to here and then reverse it and go back around there. Otherwise you tell it to go through the draw and you don't come out with good results with that. So it is a problem, and and that's what we're going to do with bearing. And bearing is used in navigation. And another way of navigation, to add more confusion to it, is that navigation can be written in terms of north and south. And then what you can say is that you're going north so many degrees east, or north so many degrees west, or south so many degrees east and south so many degrees west. That's another thing they use. So then that everything is between 0 and 90 degrees, and there's no negatives. So if you, what you would do is you would call some angle that's off over here, you would call this north, and it might be, looks like 30 degrees east. And you would, once you got down to here at 90 degrees and you stopped down in here, you wouldn't go over 90 degrees. You wouldn't say north 90, you know, like if the thing was, if your angle was down here, if this was a 5 degree here, you wouldn't say north 95 degrees east, you would say south 85 degrees east. So this would be written as in terms of south, 85 degrees east. And you'd measure it this way. So it's always in terms of north-south, and then you say east or west. And if you're running out this direction, and let's just say that this is 60 degrees, then you would be north 60 degrees west. And you wouldn't measure it around this way. You wouldn't measure it from south. You wouldn't do negative angles. It's all positive. But it's always in terms of north-south direction. So that's what ships usually will use, that kind of a direction. Now they're going to talk to you about application problems on 85, and there's a distance from a point. I did one time, because I'm pretty interested in flying, and so I've been around flight service stations, and down in Missouri one time I was on a flight service station, and it was at night, and some guy called in, and he said he was low on fuel. He didn't know where the heck he was at, and he was a VFR. You can fly VFR at night, visual flight rules, because you can see the horizon. The ground looks all black, so you gotta pay attention to towns and airports and things like that to navigate yourself. Well, he just taken off from someplace up here in South Dakota, took off flying, and he'd gotten down that far, and he was running out of fuel, and he wanted to know where the heck he was at. And I was in Columbia, Missouri, and so the guy at Columbia, Missouri, had a direction finder, and he told the guy, he said, well, mic your radio and hold it for 30 seconds. And then he got the direction that the guy was away from the station. So essentially what he found, roughly speaking, was if this was Columbia, Missouri, down here, he had recognized that the guy was on a bearing out this way. And then he didn't know how far out he was. He just knew what direction he was. So then he asked him how fast he was flying, at what mile per hour, the indicator was showing. And then he had the guy turn to a heading, and he calculated the heading so that it went 90 degrees to this. And then he had him fly for so many minutes. And then he figured that he knew roughly what this distance was. And he had this guy this way. And what he needed to know is how far out, then he could tell where he was. So then he had the guy turn and come back in about on this heading toward him, so he didn't move away from that point too much. So he had him start flying back this way. Then he calculated what that distance was, and so he figured out where he was at out there. And then he told him, he said, you're right over the top of an airport. You should be able to look straight down and see some beacon. And the guy said he couldn't see it. So then he said, well, there should be another airport, Air Force base, someplace off, and I don't know where it's at, but someplace off over here. There was supposed to be an airport underneath him, supposed to be an air base over there. And he said, I'll call the air base, and I'll have them flip the runway lights off and on, so that you can positively identify where that's at. And they flipped them, and he saw it. Well, if he lands at an air base, he's got a lot of explaining to do. They'll let you land. They'll clear you because they know you're coming in, but they'll take you into custody, and impound your plane and do a whole bunch of stuff. But the guy was willing to do it because he was printer out of fuel. So he banked the plane over and started going toward it. He saw the airport right underneath it, the one that they told him was supposed to be at. And then so he lit there. But it's a good example of using trigonometry to try to locate it. There was no GPS at the time, so that wasn't something they could use. You were using all VOR stations. I don't know whether there used to be these little cone-shaped buildings. These buildings with cone-shaped thing on the top of them. They were VOR transmitters, and you could turn to the radio station, that VOR, and it would transmit signal out, and you could go in on that radio out from there. And that's how they navigated. That's how we used to navigate. Now it's GPS stuff driven. Okay, what I'm going to do is I'm going to do some of the problems. These are a lot of word problems and a lot of problems that I've set up for you to do, but we will look at some of these things. The concept check, I want to look at page 87. And it says an observer for a radar station is located at the origin of the coordinate system. For each of the points, find the bearing of the plane located at the point. And it says use both methods. So if you had number 6, then if you're at 3, 3, then we're back here at a -3, down here at 3. Here's our point. And so we have that angle. If we use the first method, let's do it in blue. If we use the first method, it's going to be this angle, correct? So what would we say it is? 3, 3 is on a what? This cuts this angle in two, right? It's 45-degree line. So this is 45. And then this much is 180. So the angle here is 225 degrees. Now if you did the other way of describing that angle, then what we would do is we would measure it off of what? The north-south line, and we use what? South, 45 degrees west. So that'd be the two ways that you would write it. And that would be this angle right here. So let's look at maybe a couple more. These, I don't think they're too challenging. Look at 8. 8 says we're at 0 and -2. So the first way would be what? 180 degrees. And the second way would be just south. Okay. I think you probably get the idea what that one is. Now, let's look at a word problem on 16. Now, this problem is saying The ship travels 55 kilometers on a bearing of 27 degrees, then travels on a bearing of 117 degrees. Find the distance from the starting point. So, let's see. So he's going 27 degrees. So. Nuts. So that's 27 degrees, right? That's the bearing. And then you go up here, you run off your, I better maybe do 117 degrees. So 90, and then you'd have to go how much more? 17 degrees more. So this thing here is going to be 117. And to make this 90 be straight out here, so I drop down 17 degrees and then try to get some perspective to it. Now it says this is 55 kilometers and this is 140 kilometers. And they want to know distance from the starting point. What is this? So, what do you think? What do you have to figure out the degree where?
What we're trying to find out.
Why? How do you know Pythagorean theorem?
The distance of one side and the distance of the other.
But what is it for the Pythagorean theorem to apply? What is that? It has to be a right triangle, right? So what are you going to do?
I'm going to subtract 27 from the 17 to see if it is the right triangle. It comes out to 90.
So you subtract. So how did you figure out subtract 27 from 117? That's the way you have to do it. Okay. All right. Well, I guess that's an honest answer. Well, let's use some sort of scientific method here. What would be true about this angle and that angle? They'd be the same, wouldn't they? This angle here would be 27 degrees. Now, is there a way that we can calculate what this angle is? Okay, if we did 180 minus 117, right? And we get what? 63. Now then, what can we conclude? This angle right here is what? 90 degrees, so this is a right angle, isn't it? Now, we're ready to do what? Pythagorean theorem. So it's a squared plus b squared equals c squared, right? You can't, your good is okay, and you can use it on a test, but the only thing is what happens if it don't, if the gut isn't right, so now then, yeah. So what we're gonna do is the c squared equals a squared plus b squared, so we're going to do c, and we're going to do what? The positive square root of a squared plus b squared. So when we put it in the calculator, we're just going to go the square root of 55 squared plus 140 squared. And we'll do that all at once, right? What we want to do as much as possible, we just want to have the calculator do all of our calculation and do it all at once. So I'm going to go second square root, go 55 squared plus, that was 140, right? And I can just at that point, so that's 150.4. And I'm not concerned about, significant digits or anything like that. Now, before you put that down and turn it in as an answer, probably we'd just leave that off of it. What do you want to do with that thing? Does it look reasonable, right? If this number happened to have turned out to be less than one of these two, then you wouldn't accept it as an answer, right? And it can't be just outrageously higher. And you can say, well, this isn't too big, so it shouldn't be a lot more than the bigger one. If this were quite lengthy, then you'd probably want to have it to be a bigger number. So you kind of, that's where you want to do your gut, right?
So didn't come out to one. You have to do the tangent of find out the angles.
Yeah, what you do is if it came out to be more or less of 90, then you might have to do, there's actually a method that we'll learn where you can solve it, but we don't know that. But the law of sines and law of cosines. But we can even solve it without that by by taking, the height of a triangle and using, I'll draw something out a little bit. I mean, if we have solid. If we have enough information, the thing that you want to try is to extend this out, drop your hypothetical right triangle down, and then have two triangles, and try to do something like that. And then if you know the proper angles and the proper sides, you might be able to figure it out, maybe. But the law of, if you have two sides, and I think you have to know 3 items. Two sides, and that way, in that particular instance, we can get 2 sides and an included angle pretty easily, and we could calculate stuff out. Okay. Now you're on your thing. You're supposed to do 18. I think that problem would be sufficient for that. The distance between ships. This one is not going to be too much different than what we did, but its difference is it's the way it's describing the bearings. So notice it says a ship leaves its home port and sails on a bearing of 61 degrees 50 minutes east south 61 degrees, 50 minutes east. Another ship leave the same port at the same time, sails at a bearing of 29 degrees, 10 east, north 28, 10 east. If the first ship sails at 24 mile per hour and the second sails at 28 mile per hour, find the distance between two ships after 4 hours. So the home port and just so that first ship is sailing from here and it's sailing south 61 degrees east. So south 61 east would put it off in this direction. And then the other one is north 28 degrees east. So north now what I have to do, so this angle right here is what's given to us, right? And that's the south 61 degrees 50 minutes east. And then this one is north 28 degrees 10 minutes east. And then they put a little reference line in there so that kind of a hint going out this way. And then we're assuming that this one gets to here and this one gets to here, and we want to calculate that distance, right? So, now it's saying that, can we, okay, that's what I asked you. What's going to be your approach for the rest of it? Notice it's telling you miles per hour and it's telling you hours, right? So we can get a distance, right? We can get a distance for the two ships using this formula. Distance equals rate times time. Now on this ship, the rate is what? 24, and the time is for both of them is what? 4 hours. So this distance right here is going to be 24 times 4, right?
No, I think the first ship, the top one, 61. Oh, that's top.
That's the first ship, 61 degrees 50 minutes east, right? Yeah. Okay. Now, this one is 28 times 4, right? One, 2. Is that right? So we know these two sides. Now what do we need to what else do we need to know? How do we know that we can use the Pythagorean? We're gonna have to make sure that this thing is 90, right? Well, here's one way to figure it out. The angle from here all the way down to here is how much? 180. And so if we subtract the sum of these two from it, that should give us that angle, isn't it? So that means that if it's 90, the sum of these two are the sum of these two 90. Okay, so we can kind of use some deductive thinking.
That's how I did on the last one. I just did
All right, all right, okay. So now you know what the words are. So this is the 90-degree angle. So we then are going to say that that is the hypotenuse of this right triangle. And we can use that formula C equals the square root of A squared plus B squared. So we're going to do the square root of, I guess it won't make any difference which one we call which. And that should give us the length of that side, right? Now, I hope what you see is that what I'm trying to do is I'm trying to compile all the data and then put it all in the calculator once. So that the calculator does everything to the highest degree of accuracy it can and then spits the answer back. Now, these are pretty easy problems, but as they get more difficult, we still want to do that, is do our calculations, put them down, and don't do intermediate steps. Just put it all in at one time. So 147 should be our answer, right? Seven. That should be miles.
Since they're not showing us another 90, if it doesn't come out to 90, you're gonna find.
Well,
That's fine.
we're going to do some problems that don't have that for us, because we don't, we won't. This next problem is going to take us the rest of the class period to do, because we got to figure it out, because 30 is the one you got to do. I'm going to try to do 29, and the thing is a sucker to do. So because you notice that they're only giving you one length there. And there's a strong possibility I could get lost. Okay, just lay it down there, please. So they got the pyramid. That they want to know the height of. And then this is what they're trying to calculate, is this. And that's the height. It says the angle of elevation from a point on the ground to a point on the pyramid is 35 degrees, 30 minutes. Now this is angles of elevation, so it's not bearing, or it's not, this is different. So it's angles of elevation or angles of depression, and it's always measured from the horizontal. Then the angle of elevation from a point 135 feet further back is going to be 2110. So out on this extended line from the bottom of the pyramid, it's not telling you how far out, but it's just saying that at some point out here, and it's 35 degrees. So if I get some sort of, they shot a line up here, and they found that that thing was 35 degrees, 30 minutes. And that's this angle. And that's an angle of elevation, so that's what it is. Then they go back here 135 feet from here back to there. And then they're going to shoot another angle of elevation this way. And this one is 21 degrees 10 minutes. So what you see, what you're going to have to do is you're going to have to use this right triangle here and then this right triangle here and calculate what it is when you know 135. Now what you have to do is you'll have to establish this distance from here to here. This is one way to do it, as x. Now, if we consider the triangle right here, we know this angle. We're trying to calculate this, so that should be in our whatever we're trying to write an equation for. And we know part of this line that's down here. So we should use this in that right triangle. And so if we did this, if we looked at this angle, this is opposite and this is adjacent, right? So what trig function is that? Tangent. So the trig function that relates opposite to adjacent is tangent. So then we go the tangent of 35 degrees, 30 minutes is equal to h over x. Now if we take this triangle right here and h and then this side is going to be tangent of that angle, right? The tangent of 21 degrees, 10 minutes is equal to h over x plus 135. Now, if we got this equation with h by itself and this equation with h by itself, then we could set those two equal to each other and solve for x, right? And once we got x, we could put x back in here and solve for h. Is that right? That's where I'm going to go with this thing. So, and it's going to be convoluted, but so I'm going to take this equation here and I'm going to say x tangent of 35 degrees 30 minutes equals h. And then I'm going to say that x plus 135 tangent of 21 degrees 10 minutes equals h. There's other ways to approach the problem. This is just one. Now, notice that the h's, we can set these two equal to each other. Correct? So that says that x tangent of 35 degrees 30 minutes equals x plus 135 tangent of 21 degrees 10 minutes. Now what I'm going to do is I'm going to distribute this across tan x that, and I'm going to take that x something over there, factor out the x and divide. Right? See what I'm doing? So I'm going to distribute this tangent of 2110 across here. X tangent 21 degrees 10 minutes plus 135 tangent 21 degrees, 10 minutes. And that's equal to this one. Now I'm going to take this one and put it over on this side so that I have x tangent 35 degrees 30 minutes minus x tangent of 21 degrees 10 minutes equals 135 tangent 21 degrees 10 minutes. I'm going to factor my x out. Tangent 35 degrees 30 minutes minus tangent 21 degrees 10 minutes equals 135 tangent of 21 degrees 10 minutes. Now I can solve for x is 135 tangent 21 degrees 10 minutes over tangent of 35 degrees 30 minutes minus the tangent 21 degrees 10 minutes. Now don't do an intermediate step and calculate that. What you want to do is you want to go back up here where it's saying that the tangent of 35/30 equals h over x. Substitute in for that x, but actually take that x up here and use this thing right here. H is equal to x tangent of 35/30. Since h equals x tangent of 35/30, then put this in for x. So then you've got whatever that is. 135 tangent 21 degrees 10 minutes. And then that's over tangent of 35 degrees 30 minutes minus the tangent 21 degrees 10 minutes times the tangent 35 degrees 30 minutes. Remember, this is bracketed. And put that in your calculator. Don't do intermediate steps. Just put that thing in your calculator. Then you'll get the most accurate answer you can for the problem, for H. Now the challenge is how do you put it in the calculator? Well, what I can do is I can take this thing here and bracket it, put it in, put divide and bracket this and put it in the denominator, can I? Because I can treat each one of these individually. This could be 1 over this thing in a bracket times 135 times that, right? Will make no difference which way I do it, but it's easiest to see. If I put 135 tangent of 2110, tangent of 35/30, I could bracket it or not bracket it, but I'll bracket it because that's in the numerator, and then I'll bracket that denominator. So I'll go 135. Oops, and I said I told you I was going to bracket this. It will not make any difference. This part won't. Tangent 21. Now remember, I don't have this calculator set in degree mode, so but I have to force it anyway. Second angle. What in the world's going on here? Gotta go second. Angle. 10. That's 10, right? Times tangent. I want to close that bracket. I don't want to bracket. Tangent. Now this one you better bracket. If I didn't, I should have bracketed back here. I don't know what I was doing. I thought I bracketed it. This has got to have a bracket right there. You got to bracket that denominator. Tangent 35 degrees. 30. Minus 10. And close my bracket. Now if I did all my entries right, it should be that. 2894. Is that what everyone got? So I did something, I entered something wrong. Did you enter this stuff right here? Did you enter this in your calculator? I guess I could go back and see whether I entered. Yeah, there had to be 2 brackets here at the end of it. You're right. I just put 1. Yep, that's where the error was. So I can go up, then enter on this, and then do something else. Yeah, I just put 1 bracket. That still didn't. Yeah, there's something wrong with the way I entered it. When I'm entering up here, it's so darn much harder because I got to arrow it around. That's my excuse, and I'm sticking with it.
I'll let you stick with it.
Yeah, because the answer is 114. So if you put it in like that red thing over there, you should have gotten 114. Did you get 114?
Yeah.
Then you've got it in there right. I just didn't get it in right.
For the first angle was 135, first one I did was 35 instead of 21.
Yeah.
Makes a difference.
Yeah. But the thing that you want to do is put it all in there at once.
Less errors.
Yeah, because then you don't have intermediate errors. Otherwise, you have rounding errors every darn time you put an intermediate step. Okay. So Friday, Monday's the test. So Friday, if we don't have any questions, I'm going to go on to chapter 3. There'll be a quiz Friday.
I don't think I got the homework for chapter 2.
See, Dana.
No, he's right there.
I think I got it. Do I have? I have some of them. Or I have some of them. Okay. I must have, do I have? I think I got my stuff.
You handed me mine.
Oh, here. And then forward, okay?
And then I think I might actually kind of hacked around a bit with my calculator. It doesn't let me enter stuff like that.
That's a scientific calculator, it's not going to do what that one can do. No way. You have to
What do
do
you
it
mean?
individually.
Yeah. It doesn't let me
Oh,
put in
yeah,
everything
yeah.
like that. So
Well, you might have to do individual steps, I don't know how that one functions.
It's,
I've been doing it kind of just individual steps.
But if you do individual step and then take the answer out of your calculator and put it in, then it will round, and don't round it. If you're in a, if you can do that thing, let's say if you can do the numerator of the 135, can you do that thing?
Probably. I can.
You can do the numerator, get an answer, and then put divided by, and does it do answer divided by? See if
It'll
you-
bring up the answer and then I can do it.
Yeah, that's the way, so you want to do the numerator, enter the thing, and then put divided, and it should say answer divided by.
Well, it doesn't say answer. I think it goes to the next. Like,
Or else
And
either
I
that or
also-
else store that.
I also can't, I don't think I can do minutes on this either.
No,
So I've just been kind of having to, convert that.
in this class, it's advantageous to have a TI-84 plus.
or at least
Because
some
we're
kind
gonna,
of graph.
but we're gonna, yeah, well, or if you have a graphic calculator, then you bet, I'm not gonna try to figure out a different graphic calculator than this one. Because there are too many different ways of doing things in different calculators.
From what I've been doing, it's ended up getting
Yeah.
the same.
But see, we're gonna graph sinusoidal curves. You will
Oh,
you
yeah,
will
I
not
can't
know
do
how,
that.
you will not know how to do it, and there's a whole lot of that kind of stuff that we're gonna do. And inverse functions, and, there's just a lot of stuff in trig where this graphic calculator is gonna be.
Necessary.
Well, you can do it without, people have done it without, but if you,
You can buy them used on Amazon for like $50-$60.
The thing is, I used to have, but I ended up giving it to, my friend's little sister, when she
Yeah.
was taking training high school.
Yeah.
And then she was,
well,
so,
yeah, well, that's all I can tell you is that it'll be a lot handier to have a graphing calculator than not, so. And you can decide what you want to do.
figure something out, I guess.
Yeah.
Um,
Okay, what's your,
Chapter 2 homework, that book.
oh.
Yes.
Let's see, I think there's two kinds. Did you get the handout for chapter 2?
I don't think I did.
Then let's see whether there's.
Let's take home homework.
Yeah.
Alright, thank you.
Yeah.
Oh, what do you want to say?